Another thing that falls into the so easy it's hard category is what are called step functions. Now, step functions are just a kind of piecewise function whose pieces are all constant functions. So a step function is going to be just a bunch of horizontal lines. In this example, we have 3 pieces, so we're going to have 3 steps. We're going to graph this exactly the same way as we have all the previous examples. So first, cutting our graph into pieces corresponding to the pieces of the domain. In piece 1, where x is between -3 and -1, we have that f of x is -2. So the endpoints of that part of the graph will be -3, -2, and -1, -2. In this piece, x is allowed to equal -3, so this point will be in, and x is not allowed to equal -1, so this point will be out. We'll have a filled in circle at -3, -2, and an empty circle at -1, -2. Connect those, and we have our first horizontal line. No problem. This is one of those things that is so easy it's hard. You really want there to be some actual calculations involved here, and there just aren't. On piece number 2, x is between -1 and 1. And on this piece we're told f of x equals 3. So our endpoints are going to be -1, 3, and 1, 3. X is allowed to equal both -1 and 1 on this piece. So both endpoints are in. We'll have a filled in dot at -1, 3, and a filled in dot at +1, 3. And we connect those with a horizontal line. On piece number 3, x goes from 1 to 3. And on this piece, f of x is 1. So our endpoints are going to be 1, 1, and 3, 1. On this piece, x is not allowed to equal 1, so this point is out. But x is allowed to equal 3, so this point is in. We'll have an empty dot at 1, 1, and a filled in dot at 3, 1. And we connect those, again, horizontally. Remember, we're graphing a function, so we're never going to draw any vertical lines. Our step function consists of just those horizontal line segments. And what those represent is that on each of those intervals, our function just takes one value.